In this video, we're going to look at methods for solving right and oblique triangles. Solving a triangle simply means to find the measure of all three sides and the measure of all three angles. Of course, you're going to be given some of the sides, maybe one or two angles, and then you'll use the techniques that we're going to go through here to find sides that are not given. Now again, a right triangle is simply a triangle that has one right angle. And remember that all three angles add up to 180. An oblique triangle is one that does not have a right angle. That is a 90-degree angle. It could be an acute triangle, which means all the sides, or the angles rather, are acute, which are less than 90. Or it could be a triangle that doesn't have a right angle, but has an obtuse angle, an angle larger than 90 degrees. And there'll be other methods for solving those type. The most basic ones are the right triangle. So as an example here, we're given a right triangle. This is the right angle right here. This is angle C, uppercase, and then the side opposite is lowercase, that's C. And then say this is angle A over here. So this side over here would be side A. This is say angle B. The opposite side would be lowercase b. Again, the angle's given uppercase and the side's given lowercase. Now we also have to keep in mind that for a right triangle, this doesn't hold for oblique triangles, but for a right triangle, the square of the longest side, which is always a side opposite the larger angle. This is 90 degrees is the larger angle, so the side opposite that is the larger side. So the square of the largest side, which is the hypotenuse of the triangle, is always the sum of the squares of the other two sides, or the legs, also called the legs of the triangle. So we get this. So now this was a solve the right triangle if A is equal to 3 and B is equal to 4. So in this case, we're given two sides. So say A is equal to 3, B equal to 4. So I know then that C squared is equal to the sum of the squares of the other two sides. So that'd be 3 squared is 9. 4 squared is 16. 9 and 16 is 25. So C squared is equal to 25. We take the square root of that. Could be plus or minus, but since we're dealing with lengths here, we can't use a negative length. So the square root, we take the positive square root. Side C then would have a measure of 5 units. Okay, so we found this, one of the missing sides. For the angles, of course, we're given the C angle, which is 90 degrees. Then we just use the basic definitions of sine, cosine, or tangent, depending on what you're given. So here I'm going to say tangent, say angle A, by definition, is always the opposite over the adjacent. So in this case, it would be 3 over 4. Now, there's more than one way. I could go the other way and say the tangent of B is equal to 4 over 3 and find B first. Okay. So here I have tangent of A is equal to 3/4. What is A? So taking the tangent inverse of both sides, or the inverse tangent of both sides, A should equal to tangent inverse of 3/4. So I go to the calculator, check that your calculator is in degree mode. I've already done that. It is in degree mode. So then I just type in second. I want inverse tangent, so tangent inverse, and then 3 over 4, or 3 divided by 4. Hit enter. So I get 36.86. So I'm just going to say then that angle A round it out to one place, is 36.9 degrees. Since I know that one angle is 90 and then the other two are acute and they have to add to 90 degrees, to find angle B, we simply subtract 36.9 from 90, and that gives me 53.1 degrees. Now that solves a triangle. It's a right triangle. Pretty basic. Clear this. Now, if the triangle is oblique, that means it does not have a right angle. Again, it could be an acute triangle where all the angles are acute, or it could have one obtuse angle. We use these other formulas. So one of it's called the law of sines. So all it says is if you have a triangle, you can take any side, in this case I take A, over the sine of the opposite angle, so A over sine of A, and then B over sine of B, side B over sine of the opposite angle, side C over the sine of the opposite angle. Those ratios would be equal. So obviously when you're solving one of these type of triangles, you're going to use either these two, or say those two, depending on what you're given. You always want to go ahead and set up your triangle and enter the given information and then apply this formula. Notice again, look at the formula of this. You could have the sine of the angle over the opposite side. So sine of A over sine of A over side A. Sine of B over side B, sine of C over side C, whatever's convenient. Normally you put the unknown on top. That way you just multiply through by the denominator to solve for the given quantity. Clear this? Now there's a law of cosines. Tells you if you have any triangle. Again, this only want to use these formulas for oblique. They'll work for a right triangle, but you don't need them. Okay, for the right triangles, you can just use the basic definition of sine, cosine, tangent to find the sides or whatever angle you're looking for. But this one says if you take any side and square it, is equal to the sum of the squares of the other two sides minus twice the product of those two sides times the cosine of the included angle. Notice in this case, B and C, the included angle is A. So look at this, B and C, that's the included angle. C and A, B is the included angle. B and A, angle C is the included angle, and so on. But I do want to notice here, for the third one here, C squared is equal to A squared plus B squared. Notice here, if it turns out that you're using this on a right triangle, where this angle says 90 degrees, the cosine of 90 degrees is 0, so actually this term cancels. So you have your Pythagorean theorem. C squared is equal to A squared plus B squared. That's why don't use this if you have a right triangle. Now, there's 4 cases that we're going to look at. We'll go into more detail in the next video. But case 1 is a situation where you're given one side and 2 angles. So that could be given as A. The notation could be A side angle or side angle angle. These will have one solution, one triangle possible. Let me go jump to number 3. 2 sides in the included angle. 2 sides in the included angle. Again, getting back to this, so that could be side A, side B, and the included angle here would be C. Or side A and C, the included angle would be B, and so on. So two sides in the included angle are known or given. This notation is side, angle, side. Number 4, three sides are known. That'll be side, side, side. Notice here, I can't start off with the law of sines, because for the law of sines, I need at least one angle. Here I'm not given an angle. So what you want to do is this. If you're given case 1 and 2, either one, you use the law of sines. If you have the situation that's either case 3 or case 4, then you use the law of cosines. So for 1 and 2, it's law of sines. For 3 and 4, it's law of cosines. Now, in 3 and 4, it doesn't mean that eventually you cannot use the law of sines. You can. But you start off with the law of cosines. 1 and 2, law of sines. Now, 2 is called the ambiguous case, because whenever you're given two sides and the angle opposite one of the sides, you have three things that can happen. You can either have one unique solution, that is, one triangle can be formed, two triangles can be formed, or there's no triangle possible, no solution. So to kind of illustrate that, I have this right here. So let's suppose that this is angle A, and let's say this is angle B, and say angle here is C. Then I would label this side here opposite angle B as lowercase b. This is angle C, so this will be side C. And this side here that didn't complete, I'll tell you why in a minute, would be side A. So the given information then in this case would be two sides, that would be A and B are given, and the angle opposite of one of the sides. So here's angle A given. It's opposite side A. So here's what can happen. The red line that I have there, it's a perpendicular drop from C. You can think of that as the altitude of the triangle. So this is a scenario you can have. If A is greater than or equal to, so let me just write it here. If side A, and it's best to set up your triangle this way, even though this might change. This could be C, and this could be little c over here. But in this orientation, it's probably the best way to do it. If A is greater than or equal to side B, the other side that's given, then this would come out here, or could intersect over here, but there's going to be one triangle possible. If A is greater than or equal to B, there's only one triangle possible. You don't have to worry about anything else. Now, what happens if side A is exactly the size of this altitude? If A is equal to this altitude right here, and notice I want to point this out to you, you can find the length of that altitude, because the sine of angle A, if I label this as H, the sine of angle A is the opposite. This is a right triangle here. I can use your basic trig definition. This would be H over B. So the length of the altitude would simply be the sine of A multiplied by B. So this is H here. H is equal to B times the sine of A. This is an A here. So you can compare those. This will be given, A will be given, angle A will be given, and you can compute the length of the altitude and compare them. If A and H are the same, then you have one triangle possible, and it'll be this triangle here formed by the altitude. But I'm going to show you a technique where you don't have to even go through that. Okay? So those are the scenarios. If A is greater than or equal to B, this side given, this side given, A greater than or equal to B, you have one triangle possible. Not to worry for that. If A is equal to the length of the altitude, you have one triangle possible. and that would be a right triangle. Now, if it turns out that A is greater than the altitude, but less than B, then you have two triangles possible. So in that case, what happens is you could have this side intersect, say, something like this, and over here on this side, as long as it's less than B, greater than H but less than B, you can have this scenario. So you could have this triangle right here, which would be an obtuse triangle. This angle right here would be obtuse, and then this other triangle formed over here with this one would be an acute angle. But that's what we're going to focus on a little bit more in the next video, because other than that, it's just plug it into the formula. So let me give you one example of what we have, and I'm going to use this triangle here. Let me go ahead and close this. So there's my triangle here, and I'm going to label this side as B, this side is C, this will be angle A, so this side over here would be little a, this will be B, this side over here, and forget about the altitude for this one, this will be C. So let's suppose we want to solve the triangle if C, side C is equal to 5. C is equal to 5, we know that's given. And then angle C is equal to 95 degrees. And angle B is equal to 45 degrees. Now again, the only one you really have to worry about is the situation for law signs where you have side-side angle. When you're given two sides and the angle opposite one of the sides. We don't have that situation here. Okay, we're given the two angles and one side. So obviously then we want to find the measure of all the sides and all the angles. Okay, so we already have two of the angles. So we're given angle C and B. So from that we can find angle A. Because we know the sum of the angles has to be 180. So 95 and 45, that's 140. So what's left over? 40 degrees. Okay, so that's one of the answers. Or part of the answer, because we have to give them all. Okay. So we have all three angles. Two of them were given, and we found the other one simply by adding those up and subtracting from 180. So the other case that we need is what? We need B. So let me do it over here. We need side B. Let me do it on this over here. So side B is unknown, and that should be over the sine of the opposite angle, which is B. And B is given to be 45 degrees. So I'm using the law of sines. So then I take any other side over the sine of the angle opposite. So what do I have? Well, I have C is given to be 5. So let's take C. C is given to be 5. So I'll put it here, 5. And that's over the sine of the angle opposite. And of course C is 95 degrees. Okay, so now all I got to do is solve this equation for B. Very straightforward. 5 divided by the sine of 95 multiplied by the sine. So I got to multiply by the sine. Uh, 45. degrees. So obviously it's going to cancel on the left side. So on the right side it would be 5 over the sine of 95 times the sine of 45. So here's where I go to the calculator then. So do the first right side first. So it'll be 5 divided by the sine of 95 degrees. Hit enter. That computes that. And then I'm going to multiply that answer by the sine of 45. And hit enter. So that tells me that B, if I run this out to two places, 3.54, then a 9, so 3.55. So let me just say that B then, side B is equal to 3.55. That's the two decimal places. I got that. Now, we're missing side A. Okay, we have all the angles, we're missing side A. We got B, we already got C. So, for the next one, then I'll just have side A divided by the sine of the opposite side. Okay, so that'll be the sine. And the opposite angle to that is 40 degrees, so sine of 40 degrees. And notice I'm going to use the same ratio here. This one right here. Because it doesn't matter as long as you have side and sine of angle, side, sine of angle. So I just put 5 over the sine of 95 degrees. Oops. So again, just like the other one, I'm just going to have 5 divided by the sine of 95 multiplied by the sine of 40. Let's go back to the calculator. 5 divided by the sine of 95 and hit enter. It gives me that number, and then I'm going to multiply that by the sine of 40 degrees. Hit enter, and we get side A is equal to 3.226. So to three places, then I would simply say that side A is equal to 2, or 3 I should say, 3.23. 3.23. So now I have all the missing information. Got all the angles, have all the sides. That concludes this solution. Again, we'll focus more on the ambiguous case in the next video. Thanks for watching. We'll see you next time.